Hello, Miss Terry here, and welcome to Composite Functions. First of all, what are these things? Well, we have to do composite functions with two functions to begin with. We can't do the problems unless we have these two functions, and usually they name these f of x and g of x. You will be putting one function into the other function. If we input the g of x function into the f of x function, the denotation will look like this. You will notice that it says f with an open circle and g. This is not the same thing as the multiplication dot. This is an open circle. So this means f at the function of g. And there's another way to write it. We can write it with parentheses, and you will see here that f parentheses g of x is another way of saying f at the function of g. Now let's pretend we were given our two functions. F of x is equal to 4x plus 2 and g of x is equal to 3x. We're going to be given our x values. We will always know our x values. We can name them whatever we want to in our table. We will plug these x values into g of x, and then whatever value we get there, we will plug that value into the f of x function. If I throw 5 into the g of x function of 3x, I get 3 times 5 equals 15. And then if I plug the 15 into the f of x function, I will get 4 times 15 plus 2. And we will get that f at g of x is equal to 62. Let's try this same concept in the opposite way. Again, we're going to be given our two functions. We're going to name them f of x, g of x. We're going to be putting one function into the other function. This time, we will be inputting the f function into the g function, and it will look like this. G of x, again, we got the open circle, or you can write it with parentheses, g parentheses, f of x function, close parentheses. Let's use the same two functions. F of x is 4x plus 2. G of x is 3 of x. We're going to be given our x values. We will plug our x values into f of x, and then we will plug that into the g of x function. Let's pretend that x value was 5. If I throw a 5 into the f of x function, I get 4 times 5 plus 2 equals 22. And then I plug that into the g of x function, which is 3x. And I will get 3 times 22. So therefore, g of f of x is going to be equal to 66. Let's find composite function of the given functions. This time we're not going to be given a value. We are just going to find the composite function of the given function. We are given that our f of x function is 3x minus 6. And our g of x function is 4x, and they want us to find f of g of x. So I'm going to begin with the f function, and in place of x, I'm going to throw the g of x function in here. What is the g of x function? It is 4x. And if I do some simplification, 3 times 4x is equal to 12x, and then I bring down my minus 6. So f of g of x is equal to 12x minus 6. All right, let's find the composite function of the given functions. You will notice that the functions are the same. F of x is 3x minus 6, and g of x is 4x. This time we will be finding g of f of x. So we will begin with the g function, and in place of x, we will throw in the f of x function. What is the f of x function? It is 3x minus 6. And you will notice here this is distributive property. Therefore, I am left with 12x minus 24. So therefore, g of f of x is equal to 12x minus 24. Okay, find the composite function of the given functions. This time we have f of x is equal to 5x and g of x is equal to x squared, and they have asked us to find f of g of x. This time I will begin with the f function and throw the g function into it. What is the g function? The g function is x squared, and if I multiply 5 times x squared, I get 5x squared. So therefore, f of g of x is equal to 5x squared. Okay, here we have the same functions, except this time they have asked us to find g of f. So I will begin with the g function, which is x squared. So they want us to take the f function and throw it in there and square it. What was the f function? 5x. And then square it. If I simplify this, I will get 25x squared. Therefore, g of f of x is equal to 25x squared. Okay, let's find a composite function of the given functions. This time we have f of x is equal to x squared plus 3, and g of x is equal to x plus 2. It asks us to find f of g. So I will start with the f function, and they want us to throw in the g function. So therefore, I have the g function squared plus 3. What is the g function? The g function is x plus 2 squared, and then plus the 3 that is still there from the f of x function. I'm going to go over to the side over here to figure out what x plus 2 squared is. X plus 2 squared can be written like this. We can use FOIL to determine what the answer is, or we can use box method. If we used box method, I have x plus 2 times x plus 2. That gives me x squared, positive 2x, positive 2x, and positive 4. So therefore, I am left with x squared plus 4x plus 4. And you will get that same answer if you do that with the FOIL method. So, therefore, this part of the problem is equal to x squared plus 4x plus 4, and I'm still going to bring down my plus 3. I can simplify the 4 plus 3 on the outside, so therefore my f of g of x is equal to x squared plus 4x plus 7. Okay, next we will be using the exact same functions. This time we'll be finding g of f. If we start with the g function, we want to plug in the f function into the g function. What is the f function? the f function is x squared plus 3, and then we still have the plus 2 that came from the g function. You will notice that I can put my 3 and 2 together, so I am left with x squared plus 5. So therefore, g of f of x is equal to x squared plus 5. Thanks for viewing Composite Functions, and be sure to hit that subscribe button to hear about new and exciting ways to make math easy. You can also reach me at mathwithdavid@gmail.com, or if you're interested in live tutoring, you can reach me at www.tntcenter.com.